Language models, or LMs as they're often called, have a sneaky habit of memorizing and spitting out chunks of their training data word for word. This phenomenon is known as regurgitation, and it's been a growing concern in the field of artificial intelligence. Researchers from the University of Washington and the Allen Institute for Artificial Intelligence have tackled this issue head-on with a new method called paraphrase preference optimization, or ParaPO for short. In this paper, they explain how ParaPO works, why it's effective, and how it compares to other approaches. To understand ParaPO, let's first dive into the problem it addresses. When language models are trained on massive datasets, they don't just learn patterns and structures, they sometimes memorize entire passages verbatim. This can be useful in some cases, like when you want the model to recall a famous quote from Abraham Lincoln's Gettysburg Address. But in other situations, especially during creative tasks or open-ended generation, unintentional regurgitation can lead to serious issues. For instance, it might violate copyrights if the model reproduces protected text, raise plagiarism concerns in educational or professional settings, or even expose private information that was in the training data. The challenge is to reduce this unwanted behavior without crippling the model's overall performance, which includes its ability to generate useful and creative output. Enter ParaPO, a post-training technique that fine-tunes language models to prefer paraphrased versions of memorized content over the original exact text. The idea is straightforward but clever. By using preference optimization, the model learns to rank and choose responses that rephrase known segments rather than copying them directly. In practice, this involves creating a dataset where the model is trained on pairs of responses, one that's a direct regurgitation and another that's a paraphrase, and then optimizing the model to favor the paraphrase. This way, when the model generates text, it leans towards rewording things in its own style, reducing the risk of verbatim reproduction. The researchers designed ParaPO to be flexible and effective across different scenarios. For example, they developed a variant that incorporates system prompts. These are special instructions given to the model at the start of a generation task, allowing users to control when regurgitation might be appropriate. Imagine you're writing a history essay and you want the model to include an exact quote. With this variant, you could prompt the model to recall it accurately. But in creative writing or everyday tasks, you could instruct it not to regurgitate, and ParaPO ensures it complies by favoring paraphrases. To test ParaPO, the team experimented with popular language models like Llama 3.1-8b and the instruction-tuned Tulu 3-8b. They evaluated it on various datasets focused on unintentional regurgitation, such as creative writing prompts. The results were promising. On Llama 3.1-8b, ParaPO achieved a 25.4% reduction in unintentional regurgitation during creative tasks. That's a significant improvement compared to unlearning methods, which are techniques designed to make the model forget specific data. Unlearning worked well in targeted domains but only managed a 2.3% reduction outside of those areas, showing that ParaPO is more broadly applicable. When they applied ParaPO to the Tulu 3-8b model and combined it with system prompting, the benefits were even clearer. The model reduced unintentional regurgitation by 27.5% in creative writing when explicitly told not to regurgitate. Without ParaPO, simply prompting the model not to copy text only led to a marginal reduction, highlighting how fine-tuning with ParaPO makes the model genuinely better at handling these instructions. One of the key strengths of ParaPO is its balance between reducing risks and preserving utility. Language models rely on memorization to some extent for things like recalling facts or generating coherent text, so any method to curb regurgitation has to be careful not to throw out the baby with the bathwater. ParaPO addresses this by targeting only the verbatim reproduction while leaving the model's general knowledge and creativity intact. The researchers point out that both unintentional regurgitation and intentional quotation recall stem from the same memorization mechanisms, so their approach uses preference optimization to differentiate between the two based on context. In terms of implementation, ParaPO is described as a simple and efficient post-training method. It doesn't require retraining the entire model from scratch, which means it's computationally feasible and can be applied to existing models without massive resources. The paper includes details on how they prepared the training data, which involved identifying memorized segments from the pre-training data and generating paraphrases for them. This process ensures that the model learns a generalizable skill, meaning it can reduce regurgitation even on data it hasn't specifically been trained on. Comparisons with other methods are insightful. Traditional approaches like data filtering during pre-training or unlearning techniques focus on removing or suppressing specific memories, but they often fall short in real-world scenarios. For example, if you unlearn a particular dataset, the model might still regurgitate from unrelated sources. ParaPO, on the other hand, teaches the model to handle memorization more intelligently across the board, making it a more robust solution. The paper also touches on broader implications. As language models become more integrated into daily life, from writing assistants to chatbots, minimizing regurgitation is crucial for ethical AI development. It helps maintain user trust by reducing the chances of unintended disclosures or legal issues. Plus, by encouraging paraphrasing, ParaPO could even enhance the model's creativity, leading to more original and diverse outputs. In their experiments, the researchers used specific examples to illustrate ParaPO's effectiveness. For instance, when prompted to complete a text from Harry Potter, the fine-tuned model generated a paraphrased version instead of copying the original lines. This not only avoided regurgitation but also kept the response relevant and engaging. They also tested it on prompts like starting a novel with a given phrase, where the model produced fresh continuations rather than falling back on memorized content. Overall, ParaPO represents a practical step forward in aligning language models with human values. By fine-tuning models to prioritize paraphrases, it addresses key challenges in AI safety and reliability. The authors have made their code, data, and models publicly available on GitHub, encouraging further research and adoption. This openness could lead to even more refinements and applications in the future, as the AI community continues to grapple with the trade-offs of powerful language technologies.